Hello guys, so today I will be making a Phillips head screwdriver in Onshape. This is a viewer requested video and an extension of the screwdriver that we made in a previous video. Without further ado, let's get started. First, go to your screwdriver file, select or right click on the blade part and duplicate it. You can rename it if you want to. For the sake of organization, I will rename this new part Phillips head. Now going to this part, I will delete sketch 2 and extrude 2 as they're no longer necessary. Go to your variable table and create the variable length, which will have the value of 2.85 millimeters, and shut it off. Now start a sketch on the right plane using Shift S, press Shift 4 to go to the right view, press L and then Q for a construction line from the origin point out after the part itself. After you've done this, press Escape and then L, and then create a line in the inside portion of the part here. The line should be completely horizontal and should have the horizontal constraint as shown by the horizontal line near my cursor. After it has been created, press D and then dimension this line to be length. As you can see, this caused the error where our center line is no longer past this point here. To fix this, we can simply drag it out, select this point right here, zoom out, and then select this line. Press I for the coincident constraint to make sure that this line or this point always stays connected to this line right here. As for the length itself of the line, we want it to be the variable length times 4, and we want this line to consistently be 2.5 millimeters apart from the center line here. Press L again and then create another line. The length of this line does not matter, as we will then press E for the equivalency constraint. Select this line and then this to make sure that they stay the same length. Press I and then apply the coincident constraint to this line as well. As for the distance between them, it should be a distance of 2.85 millimeters. Now press L and then create a line from here to the midpoint of this upper line. We can find the midpoint, or we can select the ending point of this line and this line itself. Press Shift M, or go up here and select midpoint to apply the midpoint constraint. As you can see, we also need to apply the coincidency constraint to this line as well. After this has been done, press L for another line. The length of this line does not matter particularly, though for the sake of demonstration, I will dimension this line to be 0.4 meters in this length and 0.56 millimeters in this length. I will delete both of these dimensions as they are not necessary and were purely for displaying purposes. Press Shift M and select this point right here. The radius for display has to be 1.5 millimeters. Then press A for a 3-point arc. Select this line and this point right here. Drag it up until you see this tangency constraint. The bottom line should be highlighted and you should see the constraint near your cursor. If for whatever reason you don't, as here, select this point, make sure that it's coincidentally constrained to this line, Then press P, select this line and the bottom line to apply the constraint itself. As you can see, the coincidency constraint applied itself and has connected it, though they will not consistently remain connected. Now press L and then close the sketch that we have made. After closing the sketch, finish it, and then hide part 1. Press Shift W for the revolve feature. Revolve this outermost sketch with this central axis. Select Revolve, merge with all, and confirm. Now, make sure to show sketch 2. Press Shift W again. Select this inner sketch. For the revolve axis, select the inner axis. Then show part 1. Part 1 should look like this after your first revolve. Now, switch to remove for revolve 2. Merge with all. And for the revolve type, it should be one directional with a revolve angle of 45 degrees. After doing all of this, confirm your sketch, or confirm your feature. And now we want to do a circular pattern of this exact same feature. To do so, between the external thread and the mirror features is the pattern features. If you don't immediately see circular pattern, select this dropdown and select circular pattern. So for the pattern type, make sure that it says feature pattern. For the feature, select this second revolve. For the axis of pattern, select the central line from sketch 2. Make sure your instance count is 4, and to also reapply features. This helps prevent any glitches or errors. After you see this result, confirm your pattern. Now press Shift F for flaying. Flay each of these edges by a radius of 0.25 millimeters. Once you've done that, press Shift F again, select this backmost piece and the frontmost piece, and flay both of them by a radius of 0.13. Once you've done this, you can hide sketch 2, and congratulations, you have your flay, or you have your Phillips head bit for the screwdriver. To display the variability of the length, or the use of the length variable here, as you can see, if I adjust the value of length, the head itself will adjust itself accordingly. This can be extremely useful to have better scalability and variability with your designs. Please remember to like and subscribe, and have a good day.